So here we have a basic Newton's second law problem here, and if you recall, Newton's second law tells us the acceleration of an object is equal to the net force or the unbalanced force acting on the object divided by the object's mass. So here we have Ashley. She pushes her 0.172 kilogram phone with a net force of 4.5 newtons. And that net force is the unbalanced force acting on it. So we're going to find out what the acceleration is of her phone. So our acceleration is our unknown. We know the mass of the phone is 0.172 kilograms. And we know the unbalanced or the net force is equal to 4.5 newtons. So we'll go ahead and plug this into the equation. Acceleration is what we're looking for still. 4.5 newtons divided by the mass of 0.172 kilograms. So when we work that out, we get 26.2 newtons per kilogram. But what's a newton per kilogram? We've talked about accelerations in terms of meters per second, but never looked at a newton per kilogram. So one of the things we have to remember is that a newton itself equals a kilogram times a meter per second squared. Remember, it's just the force required to accelerate a 1 kilogram object 1 meter per second squared. So if I substitute in that in place of the newtons here, I'm going to get kilograms times meters per second squared, all that divided by the kilograms on the bottom. And so those kilograms will cancel out right there. That leaves me with meters per second squared, or meters per second. And that makes sense. So a newton per kilogram is actually the same thing as a meter per second squared. So we have an acceleration of Ashley's phone of about 26.2 meters per second.